Welcome back to the channel, everyone. Today's video is going to be an incredible journey into the fascinating world of artificial intelligence, where we'll focus on one of the most practical, jaw-dropping, and powerful applications ever created, solving math problems at lightning speed. Whether you're a student struggling with algebra, a teacher trying to create lesson plans, a researcher crunching numbers, or simply someone curious about how technology is reshaping our daily lives, this topic has something for you. In this video, we'll explore the evolution of math-solving AI, the underlying technologies, its jaw-dropping benefits, the surprising limitations, the ethical challenges, and the futuristic possibilities of where this innovation might take us. Before we dive into the details, make sure you smash that like button, subscribe to the channel for more deep dives into AI and technology, and drop a comment below letting us know the hardest math problem you've ever encountered, and whether you'd trust an AI to solve it for you. Let's dive in. 1. The evolution of math-solving AI. Math-solving AI has gone through an extraordinary transformation over the last several decades, starting from simple mechanical calculators that could only handle basic arithmetic, then moving into scientific calculators capable of trigonometric functions, logarithms, and exponents, and then advancing to rule-based computer systems like early computer algebra programs, which could manipulate symbols and solve equations under strict programmed rules. As computing power increased and machine learning entered the picture, we saw the creation of systems like Wolfram Alpha that could take natural language input and compute advanced answers. But the real revolution came with the rise of deep learning and neural networks that can not only process text, but also understand the context of mathematical problems. These AI models can interpret natural language word problems, translate them into symbolic mathematical structures, and solve them step by step while explaining the reasoning. The journey from rigid calculators to adaptive neural solvers reflects the convergence of computational speed, symbolic reasoning, and language understanding, creating tools that feel less like calculators and more like intelligent tutors. 2. How AI understands math problems. At the heart of AI's ability to solve math lies natural language processing combined with symbolic reasoning, enabling the system to bridge the gap between human language and abstract mathematical expressions. When a student types or speaks a question like, "What is the integral of 3x squared plus 2x?" the AI breaks the sentence into components, identifies keywords, and constructs a formal representation of the problem in mathematical notation. Unlike old calculators that required precise syntax, these AI systems are trained on vast datasets of problems and solutions, learning to map words like sum, difference, or factor into symbolic equivalents. Once the equation is built, the AI uses symbolic algebra systems or computational engines to carry out the operations, delivering not only the final answer but also an explanation that mirrors how a human teacher might present it step by step. 3. Speed and accuracy advantages of AI. The sheer speed and accuracy of AI in solving math problems is one of its most remarkable features, highlighting why these tools are becoming so widely adopted across education, research, and industry. Imagine a human mathematician faced with solving a system of differential equations. Even for experts, this could take hours of work, and AI, by contrast, can perform the same computations in milliseconds, delivering precise answers and detailed explanations. Unlike humans, AI doesn't get tired or careless. Every calculation is performed with exact consistency. 4. Applications in education. One of the most transformative impacts of math-solving AI can be seen in education, where these systems are changing the way students learn and teachers teach. Students now have instant access to AI-powered tutors that can walk them through solutions step by step, explaining the logic and providing alternative methods when needed. This isn't just about giving answers. It's about guiding understanding and mimicking the patience of a one-on-one teacher available at any hour. Teachers benefit as well, using these tools to design adaptive lesson plans, generate practice problems, and evaluate student progress more precisely than before. 5. AI in scientific research and engineering. Beyond the classroom, the role of AI in solving math problems has become indispensable in scientific research and engineering, where equations and models underpin discoveries. Complex systems of equations are central to physics, chemistry, biology, and engineering, and researchers often spend enormous amounts of time working through them. AI can process massive datasets, recognize patterns, and solve equations on a scale that was previously unimaginable. In climate modeling, AI predicts weather changes with unprecedented accuracy. In medicine, it accelerates drug discovery. Engineers designing bridges or spacecraft use AI to run countless simulations, each requiring advanced computations, allowing them to test safety and efficiency under different conditions in a fraction of the time. 6. Real-world problem solving. AI math solvers extend far beyond classrooms and labs into industries where problem-solving speed directly impacts success. Businesses rely on AI-driven modeling for financial forecasting, supply chain optimization, and logistics management. Banks and investment firms use AI to run risk assessments and predict outcomes with greater confidence. Urban planners use it to calculate traffic flow and energy consumption for smarter cities. Even machine learning itself relies on solving massive optimization problems, making math-solving AI both an application and a foundation of its own development. 7. Challenges and limitations. Despite their capabilities, AI math solvers are far from flawless. One hurdle lies in interpreting ambiguous language. If a problem is poorly worded, AI may misinterpret it. Another limitation is creativity. While AI excels at applying known methods, it struggles with problems requiring an intuitive leap. Over-reliance on AI can also become dangerous, especially when users trust outputs without verification. A small error in high-stakes calculations could have serious consequences. Furthermore, these systems often require significant computational resources and may lack transparency in their decision-making, leaving users uncertain about how a solution was derived. These shortcomings highlight why AI should be used as a tool with human oversight. 8. Ethical and educational concerns. The rise of AI math solvers raises ethical and educational concerns, especially in how they affect learning and critical thinking. Students now have unprecedented access to tools that can guide their learning, but the temptation to misuse them is significant, with some relying on AI without developing their own problem-solving skills. Educators face the challenge of integrating AI in ways that enhance rather than undermine learning. Beyond education, ethical concerns also extend to fairness, as access to advanced AI tools may be limited to those with resources, creating inequality. Striking the right balance will be essential to ensure that AI empowers rather than diminishes human learning and equity. 9. The future of math-solving AI. Looking ahead, the future of AI in mathematics promises to be even more revolutionary. Multimodal AI that can process text, diagrams, graphs, and handwritten notes will allow it to tackle geometry or physics problems more naturally. Imagine sketching a triangle and the AI instantly calculating properties while explaining each step. Collaborative systems are on the horizon, where humans and AI brainstorm multiple approaches together. Integration with quantum computing could further supercharge AI's ability to handle complex equations, unlocking solutions that even today's most powerful supercomputers cannot attempt. 10. Why AI will never replace human mathematicians entirely. For all its power, AI will never fully replace human mathematicians, because mathematics is not only about solving equations, but also about creativity, abstract thought, and invention. AI is brilliant at applying known techniques, but when it comes to asking bold new questions or devising untested frameworks, human ingenuity remains unmatched. Breakthroughs often come from inspiration, metaphorical thinking, or aesthetic judgment, qualities machines cannot replicate. Instead, the future will see a partnership where AI handles computation while humans provide vision and creativity. We've explored the evolution of AI math solvers, how they interpret language, their breathtaking speed and accuracy, their applications in education, research, and industry, their challenges and limitations, and the exciting future that lies ahead. What's clear is that AI is not just changing how we do math, it's reshaping how we think about learning, problem solving, and collaboration between humans and machines. If you enjoyed this exploration, don't forget to smash that like button, subscribe to the channel for more content on AI and technology, And leave a comment below telling us how you'd use an AI math solver in your own life.